Okay, we're going to walk through a few examples now. You're going to need your GeoGebra open, you're going to need your statistics calculator, and you're going to need your spreadsheet view. Now, before we start, I recommend that you add your data into the spreadsheet view. This first row of data, where it says before, that should go in your column A. And where it says after, this row of data should go in your column B. So pause the video and get that set up, and then we'll get started. A tech company wanted to test whether adding live planks to employees' workstations increases productivity. To investigate this, the company randomly selected 12 employees and measured how many tasks each completed during a typical 8-hour workday before the planks were added. Then, after 2 weeks of having planks at their desk, the company measured the productivity again for the same employees. Assume the differences in the task completion rates are approximately normally distributed and the observations from one employee to another are independent. The company wants to know whether the presence of planks led to an increase in the average number of tasks completed. So we have this data. We have 12 employees in total. This 15 was the number of tasks that employee 1 had completed before the planks were at their desk. And then after the planks were there for 2 weeks, this person had 18 tasks completed. So these two values have a connection to the same person. And so we're going to call this dependent, which means we're going to use the process called matched pairs. Because we're checking to see if the number of tasks after is larger than the tasks before, if I take this set of values and I subtract this set of values, if I take a smaller and minus a larger, that's going to be negative. So when we set up our alternative hypothesis, we're going to say mu d is less than 0 because we're checking to see if I take a smaller number and subtract a larger number, what we're going to get. So we're expecting that to be less than 0. We're using an alpha level of 0.01, and because we have a less than, this is going to be left-tailed. Now for step 2, as usual, we need to find the test statistic and the p-value. Now here's where there's a little bit of a different setup. The values in column A are the before scores, and the values in column B are the after scores. And what we need to do is we need to find the differences between all of these and then test just that column. We want to treat column C as a set of data as a separate sample, and that's what we're going to test. So rather than find the differences by hand, there's a quick way you can do this on the spreadsheet. I'm going to say, in column C, I'm going to say equals, because we're going to do some math, and this is the same way you would do it on Excel. So you would hit the equal sign, and then I'm going to say take capital A1, so cell A1 minus cell B1, and I'm going to hit enter, and it's going to calculate that for me. Now, if I want to apply that to all of this, I'm going to do a copy, and then I'm going to paste it down here, and it will automatically do that for the other values. So we have 15 minus 18 is a negative 3. We have 20 minus 22, that's a negative 2. 18 minus 20, that's a negative 2. So if you do a quick spot check, you can make sure that it works. And so now we need to run a t-test on this data, the set of differences. So I'm going to highlight these values, and I want to figure out what those statistics are. We need the mean and the standard deviation and all of that. So I'm going to choose the histogram, one variable analysis. I'm going to choose this symbol here to get our statistics. And so we can see that our mean is negative 2.3333. And our standard deviation for the sample is 0.8876. And so we need that to put it in for our t-test. So we're going to write that down. So I'm going to make a note here. Our mean is equal to negative 2.3333. I suggest that you keep all the digits to make sure you get the right answer. Don't round it during intermediate steps because it will throw your answer off. Okay, then we're going to put our standard deviation down because we're going to need this. S equals, and then 0.8876. All right, now we have what we need to complete our t-test. So I'm going to close this out. I'm going to go to the Statistics tab, and I'm going to do a t-test. Now we're treating this list of differences as a single sample, one sample. Okay, so when we're doing the differences, the null hypothesis, that's going to be equal to 0. We're doing a less than test, so this is going to be left-tailed. And here's what we're going to put in. We're going to put in our mean, that was negative 2.3333. We're going to put in our standard deviation, which is 0.8876. And then we're going to put in our value of n, which was 12. We had 12 pairs. And you can also see that from this list here, it goes from 1 to 12. Okay, now when I enter all of that in, we get our test statistic down here. So I'm going to put in that our test statistic is negative 9.1063. And our p-value is so small it rounds to 0. All right, the next step is to find the critical value and use the rejection region. So I'm going to go to my distribution tab. Now we're using the student t distribution here. We're doing a t-test. We always do a t-test with matched pairs. My degrees of freedom is 1 less than the sample size. Here I have a sample size of 12, so my degrees of freedom is going to be 11. This is a left-tailed test. I'm going to choose the left bracket. And then I want to put in that we have an alpha level of 0.01. So my critical value, my boundary for the rejection region is negative 2.7181. So if the test statistic falls in this red area, anything less than negative 2.7181, we're going to reject. So negative 2.7181. If it falls in the blue area where it's greater than negative 2.78181, then we're going to say do not reject. So when we look at our test statistic, we see we have negative 9.1063. That's definitely less than negative 2.7181. So we're going to say reject the null hypothesis. Now let's look at step 4, which is the p-value method. My p-value is 0. My alpha level is 0.01, and 0 is definitely less than 0.01. So again, we're going to say reject the null hypothesis. Now for step 5, we're going to write our conclusion. So we're going to say, since we are rejecting HO, there is enough evidence to suggest that the alternative hypothesis is true. So I'm going to say at the 0.01 level of significance, there is enough evidence to support the claim that plants increase work productivity. So there's our conclusion. Let's look at example 6 now. A study comparing commute times between taking a cab versus the T in Boston during rush hour measured the same route for 9 people. Each person took the subway one day and then a cab another day. Does taking the T get you to work faster? We're going to use an alpha level of 0.05. Now it says they're measuring the same route for 9 people using the T and then taking a cab. So this person right here, this is the time it took for them to take a cab, and then this is the time that it took for them to take the T. And then, so because this 45 and this 38 is coming from the same person, there's a direct connection between the 45 and the 38. So this is dependent. Now we're looking to see if taking the T gets us to work faster. So we're expecting the values for the T to be smaller, and we're expecting it to take longer for the cab, so these values are going to be larger. So when I take the first group minus the second group, a larger number minus a smaller number should give us a positive value. So when I set up my null and alternative hypothesis, my null hypothesis is always the same for matched pairs. We have mu d is equal to 0, meaning there is no difference. And then the alternative hypothesis is mu d is greater than 0, because when we take the first list minus the second list, we're expecting the first list to be larger and the second list to be smaller. So when we subtract them, we get a positive number. We're using an alpha level of 0.05, which means this is going to be a right-tailed test. So if you haven't already, put your data values into the spreadsheet. I already have mine preloaded. I'll just scoot over. Okay, since we're using a matched pair process, I want to find the differences between all of these and then run a t-test just on the differences. So that will be my column F. So I want to say, I'm going to take my cell D1. So I need to put in my F1 cell an equal sign, because we're going to do math, and then put in D1 minus E1 and hit enter. And then I want to apply that to the rest of the values. So I'm going to copy, and then I'm going to paste it in here for the rest. Okay, so now we have all of the differences here. So we need to run a t-test on these differences, which means I need to know what the mean and standard deviation values are. So I'm going to highlight all of my values, hit the histogram button, choose one variable analysis, and then I'm going to choose this symbol here, the sigma with the X, to get my statistics. And we have, let's see, here's the mean, 8.6667. So let's put that in our notes here. So 8.6667. And then our standard deviation is 1. All right, I'm going to make this print a little bit bigger. so that I can see it better. All right, so this is what we're going to use when we go to complete step 2 to find the test statistic and the p-value. I'm going to choose my statistics tab. We're doing a t-test on the differences. My null hypothesis is mu d is equal to 0. We're doing a right-tailed test, so I want to choose this greater than symbol for our option. And I'm going to put in that our mean is 8.6667. Our standard deviation is 1, and our sample size is 9. If I scooch over, you can see that D, E, and F, I have 9 pairs. All right, so we have a test statistic of 26.0001, and we have a p-value of 0. So now we need to find our critical value. So we're going to go back to the distribution tab. We're already on the student distribution. And our degrees of freedom is the number of data values. So that's the number of differences we have, which is 9, minus 1. So my degrees of freedom is going to be 8. Now we're doing an alpha level of 0.05, and we're doing a right-tailed test. So I need to switch my bracket to the right side. And I need to put in for my alpha level 0.05. That's the area I want shaded. So my critical value is 1.8595. So that means we're going to fall in that red rejection region if our test statistic is greater than 1.595. We're not going to reject HO if the test statistic is less than 1.595. That falls in this blue area to the left of the critical value. So when we look at our test statistic is really large compared to our critical value. It's way bigger than the 1.8595. So we're going to say, for step 3, reject HO. Now let's use the p-value method. So our p-value is 0, which is certainly less than our alpha level of 0.05. So again, we're going to say reject the null hypothesis. So since we are rejecting the null hypothesis, there is enough evidence to suggest that the alternative hypothesis is true. And the alternative hypothesis, what we were testing was to see if the T got us faster to work versus taking a cab. So we're going to say at the 0.05 level of significance, there is enough evidence to support the claim that taking the T is faster than taking a cab. A university psychology professor wants to test whether the type of background music affects how well students perform on logic puzzles. She randomly assigns 10 students to Group A, who listen to classical music, and then 10 different students to Group B, who listen to electronic music. Each student completes the same logic puzzle under timed conditions, and their scores, or out of 30, are recorded. Each group is approximately normal, and the groups are random and independent. The professor will test whether there is a statistically significant difference in the mean logic puzzle scores between the two music conditions. So this group of 10 people for the classical group, that's 10 different people compared to group B. So this 24 and this 20 are not coming from the same person, and they don't have a direct connection to one another. So this is a case where we have independent samples. So we do not need to run a matched paired test here. So we're just going to run a regular 2-sample t-test. So in step 1, instead of using mu d, we're going to go back to what we were doing before for 2-sample t-tests. Our null hypothesis is that the two means are the same. And since we're looking to just see if there is a difference right here, it just says if there's a difference in the mean logic puzzle scores, we are going to make this a two-tailed test where the alternative hypothesis is mu1 does not equal mu2. And our alpha level is 0.05, and we'd have that it's two-tailed. So for step 2, we need to find our test statistic and p-value. We need to do a little bit of work to find that. I put my classical group values in column G and my electronic group in H. We do not need to find the differences between these two like we did in the first two examples because these are independent. So we're just going to find the mean and standard deviation for each group separately and then run a 2-sample t-test. So I have to find the mean and standard deviation for this group. So I'm going to choose one variable analysis and then choose show statistics. So for the classical group, we have, let's write this down. So this is for group A. We have a mean of 24.5 and our standard deviation is 1.5811. Now for group B, let's see what those values are. Okay. So I'm going to close this out and start again. So my values for group B are in column H, so I'm going to highlight that and go through the same process to get our statistics. So for group B, we have a mean of 19.5, and our standard deviation is 1.5811. Now to find our test statistic and p-value, we're going to go to the Statistics tab, and we're going to choose t-test the difference of means. We're doing a two-tailed test, so I'm going to choose not equal to. Remember to keep the pulled option unchecked. I'm going to put in the mean for the first group was 24.5. The standard deviation for the first group is 1.5811. And the sample size is 10. The mean for the second group was 19.5. The standard deviation is 1.5811. And the sample size again is 10. Once again, we have a test statistic that is large. We have 7.0712. Our p-value is again 0. Now we need to find our critical values. let's write down, because we're going to need it for our critical value, what our degrees of freedom is. Our degrees of freedom. If you look down here, it's 18. So we're going to switch over to our distribution tab. And we're going to put in our degrees of freedom as 18. This is a two-tailed test. So I'll look at the right side first, the critical region that's on the right. Since we're using an alpha level of 0.05, each wing should have 0.025 so that it adds up to 0.05. So our critical value for the right side is 2.1009. And the left side will be exactly the same, it's just going to have a negative. So if I'm looking at the rejection region in the left tail, to fall in that region, you have to be less than negative 2.1009. To fall in the rejection region that's in the right tail, you have to be greater than 2.1009. To fall in the region that's blue, where we're not going to reject the null hypothesis, that would be between the two critical values. So that would be between negative 2.1009 and positive 2.1009. When you look at the test statistic, you'll see that it's greater than 2.1009. So we're going to reject the null hypothesis. Now let's look at step 4 for the rejection region. The p-value is 0. The alpha level is 0.05. So the p-value is less than the alpha level, which means, again, we're going to reject the null hypothesis. Since we are rejecting the null hypothesis, there is sufficient evidence to support the claim that the alternative hypothesis is true. So we're going to write at the 0.05 level of significance, there is enough evidence to support the claim that there is a difference between the two groups. So I would like to emphasize, when you approach a hypothesis test with two samples, read it carefully and identify whether it's independent or dependent. If it's dependent, you have to run the test with the matched pairs, where you find the difference for each pair and then run a t-test on the differences, and you treat those differences like it's one sample.